Thanks for joining, everybody. Resilient Reconstruction is our focus. Obviously, you've joined another Markham webinar where we're all about adding life to concrete. And so that's going to be the topic today, is how do we add life in a way where we can make a structure resilient and rebuilding, playing the long game. So it's rebuilding structures. And I guess why this brought this on, we'll touch on soon, is there's a lot of rebuilding going on, a lot happening in current events, and it's brought up a focus of are we building right and what can be done. So welcome aboard. Thanks for taking time out of your day to keep learning and joining us today. So I'm Hayden Prestidge, based in Napier, and I've got with me Doug Hamlin, been with Markham for a long time and very focused on civil and infrastructure, very passionate in that scene. And then across in the other screen, we have, that's across in our Sydney office, we've got Brad Fulcher and we've got Chris Cox. It's come out of the concrete industry. So a lot of years between us. Also, hopefully we can share some insights and some learnings and help each other forward. So without waiting, let's jump on right in. Let's have a bit of a look-see at what we want to get out of this session. As far as learning outcomes, it's always good to see where we're heading. So rightio. So let's look at this, the challenges of creating that resiliency. So what's the sort of the barriers, what's the thoughts out there, what's making it hard to make a structure resilient, concrete wise we're talking, and then have a look at solutions. What are the solutions out there? Is there a win-win solution that helps people and planet and structure? And then having a look at the feasibility of getting things done, disruption and practice. What happens when we're actually things are actually needing to happen, rubber hits the road, so to speak. What does that look like? And then probably the overriding point will be act early, and what we need to do and how we can act early in view of saving things like maintenance and rebuild, essentially, again. So let's have a quick look. We've got a number on this. Cool. So let's have a quick look and share your background. Tell us a little bit about where you're from, and just helps us direct our conversation. And a little bit of everyone comes from a different sector, so it'd be good to know. So just tick that box there, and then we'll bring up these results in a second. Thanks for your input in advance. Welcome to those that have joined. Sorry we kicked off. Hopefully it's just been pretty much introduction so far, so thanks for joining. It's good spread there. A lot in the design phase, structural engineer, civil engineer, and then in the design professionals. So very good mixture there. Thanks all. That's good. So it's a lot in the space of new builds and obviously protecting current assets, probably a section of your asset managers. So good work. Now, just quickly, we will be doing Q&A at the end. It's always a good, important part of these sessions, and they always go better for the audience and ourselves when live examples come up into Q&A, and we get to talk about that and dive through that at the end. So absolutely pop down the bottom of your screen there, you'll see the Q&A box. Pop any questions in there as we go. You can use the chat as well, but try and keep the Q&A, and it's all in one space at the end. So let's do it, but looking forward to those interactions. Now, this has been brought on a bit, and we don't we just want to throw out some thoughts here that, this rebuild topic has come about because of what's happened. In no way we are saying, things are wrong with design and things. And we do want to extend our sincere sympathies to anyone affected by these events. But Doug, do you want to dive in here and help us through this one?
Yeah, sure thing. Yeah, no, just like to echo what you've said there as well. It's not we're definitely sympathetic with everyone that's been affected here, and we're not trying to say in any way that the topics we're talking about today would prevent some of the damage that happened in these events, particularly around Hawke's Bay. Some of the loadings and things were far beyond what the design was originally intended for. So what it has highlighted, though, is the need to look after concrete structures and make them more resilient, stop deterioration happening, slowly over time, in view of, getting the best service life out of that. Now, while a lot of structures may not necessarily have been completely, suffered catastrophic failure, they are affected by these weather events that are happening across New Zealand, across Australia, indeed around the world. And like I said, it's very slow, but it's a very sure thing that happens is that concrete does degrade over time, like anything, but it's specifically with concrete. And we really need to think about it a lot deeper, how we can extend that service life, make these structures more resilient, and let's do all that we can to protect against the effects of these weather events. One example that springs to mind is often when a structure is completely submerged, the concrete gets obviously saturated, gets loaded up with moisture, loaded up with contaminants, and then it dries out during the summer months. That cycle is very harsh on concrete, and it needs to be protected against. I don't know, is there anything on that over in Sydney there? Anything to add there?
No, I don't think so. Doug, you covered it very well there. Just like to also welcome everyone on board. Thank you for taking time out of your day. One of the things we are going to have a look at now is some of the impacts that these challenges can have on our infrastructure. So some of the things we're going to look at here is the cost of new concrete, the cost over the structure lifetime. So those two things are part of your original budget, if you like, and then ongoing expenses as well. What we can do to extend the service life of new structures. Our focus here is from new right through to the end of the life cycle of the structure. So these are some of the lessons that we've seen over the years. Markham's been going for a long time now, so we've seen a lot of things out there from new construction right through to trying to make things last their service life and beyond in some cases. Some of the challenges and impacts that these can affect on this is one of the things we do see is contamination of concrete. So our main focus here is on the concrete structure itself. So there's a lot of infrastructure out there, such as bridges, wharfs, wood infrastructure, those sort of things that are used every day. And as Doug was talking about earlier, are a massive part of our life. And when these things break down or are put out of action for some reason, it's really got impacts beyond what we do think at the time, just with commutes, getting to work, your goods arriving at your door, all those sort of things as well. So a lot goes into it. I was actually just trying to count up earlier of how many bridges I went past on my hour commute to work, but got lost at about 20. So there's a lot of it out there and impacts everyone in different ways. So with internal contamination, one of the key points here is that concrete can often look fine from the outside. So we see a pretty nice looking concrete structure and think, no, that's all good. That will last for another 20, 30, 100 years. But there could be a lot going on inside the concrete, which manifests itself a bit later. So we're talking things like ASR, carbonation, DEF, and of course the corrosion of the reinforcing steel, otherwise known as concrete cancer. So these things can manifest themselves a bit later in the age of the structure. And by that stage, it's actually getting to the point where major repairs need to be undertaken. So it's an important feature of these is they're all affected by moisture getting in the concrete and setting off this contamination, actually making it start happening and the deterioration of the structure starting. So it's important to try and stop that moisture getting in the structure into the concrete for a start, and just trying to keep that structure lasting as long as it can. But just taking into account that not all can be as it seems. So making sure we are looking at the the longevity of the concrete, not just from what it looks like from the outside. You had a few points, didn't you, Chris, on how to maintenance and the maintenance challenge that's faced out there by some of the guys that are on this call?
Yeah, thanks, Brad. Yeah, it's a massive challenge. Obviously, the maintenance and things like that, right from the beginning, we're obviously restricted, or you can be restricted by budget. So it plays a massive part in the actual construction phase. So don't go short on the actual maintenance side of with the budget. You'll pay a lot of extra money down the road. You'll actually see a little bit of a presentation later in the webinar regarding those sort of dollar on dollar and how it impacts the actual cost. So reducing the maintenance costs, think about it right from the start. Lengthen the maintenance cycle. Make the concrete last longer, basically. So yeah, the maintenance, don't go low on your budget, please. It plays a massive part. Brad, what's your?
Yeah, no, totally agree. And if anyone on the call's got any tips on that, please put them down in the chat or the Q&A. We really welcome those ideas and can share with the viewers as well. One of the other challenges we see more and more nowadays is what we call the carbon challenge. There's a big movement at the moment to reduce our carbon footprint of new construction and also repairs and maintenance of our old structures. So this is a really important factor, if you like, of builds. Portland cement is a major part of the emissions of concrete, the production of it, the transporting of it. So it's one thing that's been looked at very heavily across the board, really, is reducing the amount of cement in concrete or the amount of concrete in structures. So it's something that's been looked at, and obviously there's a bit of a trade-off with that as well. So, Chris, you've had a bit of experience with concrete plants. What are your comments around here?
Yeah, so obviously there's the main focus at the moment in the production of concrete in the ready-mix industry is obviously trying to reduce those carbon emissions, and with that comes new technologies, and around that new technology space then becomes space in these current plants or even the existing new plants. So they don't have the footprint at the moment to implement these new technologies. So it becomes a major issue for them moving forward. So yeah, it's a concern, but guys, there's different technologies out there. They're working through it as we speak, and they will do it in the future. But there's probably a win-win solution there. Doug might have some more information regarding the win-win solution moving forward.
Yeah, thanks, Chris. Yeah, no, good overview there. Good topics covered. So, is there a win-win solution? We feel there is. And I guess it's really around enhancing that durability, that service life, the resilience of the structure. We've talked about, the emissions associated with concrete, whether that's in new concrete or whether that's in repairs. Can we reduce that, that need by making the structures last longer? Chris touched on the maintenance topic there. Typically in concrete structures, you get like a 5 to 10 year maintenance cycle. Thinking about a bridge structure or a marine wharf, something like that, and that is a very costly exercise. And we want to can we push that maintenance cycle out to say 15 years or 25 years, whatever it may be, extend that cycle and reduce the amount of not only construction materials activity, that type of thing, but the cost effectively of that maintenance. Now, in regards to durability, it does pay off in a concrete structure. It is very key. It's the most important thing to service life, and with that, the most important measure, if you like, is the permeability of the concrete. So how quickly moisture can, flow through the concrete, and, along with moisture goes contaminants. So if we can control that permeability in the structure, we have a direct effect on the service life of that structure. Now, it is important to note that some issues start from day one of a structure's life, whether that's contaminated materials used in the concrete mix, whether it was an extremely cold or an extremely windy, extremely hot day, whatever it is, the weather's not favourable and you get shrinkage cracking, things like that. and that can set off deterioration or accelerate it rather right from early on, and we start seeing problems long before they should in concrete structures. So I guess the one of the challenges here is around the 100-year design life. In some cases, I'm seeing 120 years nowadays, and is that really achievable in the real, in real life and in the real world, so to speak? Now, obviously, from a design point of view, it is. It really gets, I guess you say, it gets let down, or that the challenges are in the construction phase. And is it possible to achieve that 100 years? Yes, it is. If that design is followed through, if there's adequate effort put in the construction phase, and then that construction, that good work that's happened is maintained over the structure's lifespan. Hayden, do you have any points on that?
No, it's good. I think concrete is the second most used consumable in the world after water. So it's there, and we need to learn how to deal with it better and extend its life. And what are we doing with it? That's good points. What you raised about permeability has been a measure, because for a long time now the industry has just focused on MPA, the concrete strength. And there's still a discussion now. If I take my MPA, from a 40 up to a 65, obviously we're using a whole lot more cement and the mix is different. That should be sufficient for durability, and it's not actually right. The point is, even a high MPA concrete will still allow ingress of moisture and contaminants and things like that. So over time. So we've got to think differently, and we've got to think about permeability, and that's probably a big challenge we want to put out there today. Is let's have a bit of a mindset shift there, shall we, on what can be done to reduce that permeability and increase that durability in doing so, and look at ways, because you can actually pull back on cement usage and content by looking at different methods of increasing its resistance to moisture migration. So I'll throw that out there, and interested in any comments you've got on that. Anyone on the call now, put on the chat or whatever, be interested. Any comments around those, what we've been talking about, and if you've worked with any similar challenges, any questions around some of those challenges that we've been talking about so far. So I thought from here, it was probably a good idea to have a bit of a look-see at what can be actually done now. Probably all sitting there with structures in our minds, but what does that mean? What does it look like? We want to put something into practice. Brad, do you want to take us away here? You've been involved with numerous projects.
Yeah, thanks, Hayden. Some really good points there around MPA and permeability. We're just me and Chris were just speaking off air earlier that we had a case study in mind where they increased MPA to get more durability on a slab pour, but actually resulted in more cracking and the end result. So it's a bit of a do one thing to get more durability, and then you've got another problem in your hand. So it's definitely something we need to think about and look into. So this first case study we'll run through is a Bledisloe Wharf in Auckland. No doubt a lot of people on this call will be familiar with this. We actually got involved in this project.
Maybe.
Yeah, won't talk about that yet. So we got involved in this project in 2001. They'd just done a condition assessment on the wharf, and it had a few issues with it. A pretty high level of chloride ions, so it's fairly contaminated. They were seeing the result of that, so they had a bit of spalling and cracking, that sort of thing. So something needed to be done. One of the recommendations in the actual report was to knock down the structure and rebuild, so replace the structure. So they actually came to us with that in mind. They were looking at seeing what we could do to keep the wharf going for another couple of years while they got their design sorted and the budget sorted to actually put a new wharf in. So that's how they came to us. We actually used one of our spray applied treatments, our Civiltech Acron 7000. So the wharf was cleaned down, and this was spray applied to the concrete. What this treatment does, it penetrates into the concrete and creates a hydrogel inside the concrete that actually locks in the contamination, but more importantly, stops more moisture coming in. So what we essentially did with the Wharf was put in the holding pattern, so no further deterioration could occur. Obviously, once deterioration is there, it's very hard to reverse it without replacing elements or parts of the Wharf. So we'll actually touch on that a little bit later about how important it is to act early. But yeah, essentially we put it in a holding pattern. They're still using that same section of the Wharf to this day, and they've actually extended on the end of it. So great result for the client, put it in that holding pattern, and stopping those contaminants from keeping damaging the concrete. Doug, any comments on that? I believe you was involved in that one also.
No, that's covered it well, yeah. And the amount of concrete, the sheer cubic meters of concrete saved on that structure, the new cement that's not needed, and they can keep using that structure. It's real encouraging. In regards of concrete, assessments, it's something we're getting involved in a bit. Brad, I think you had a few thoughts here on how going deep, how we need to look at that cover concrete. And the performance of that when we're considering that. You touched on it earlier around just not just looking at the surface, the visuals there.
Yeah, exactly. Yeah, to touch on it. So it's not just what the concrete looks from the outside. We have to see how it's performing, what's actually happening inside. So one of the things we do look at is as Doug said, the cover concrete and essentially how permeable it is. So is that cover concrete doing what it's supposed to do? So the cover concrete's there to protect the steel reinforcing and stop it from rusting and busting out. But what that cover concrete is meant to do is stop that moisture from getting down to the steel. So by testing the permeability, it's a non-destructive test we can carry out. So it's pretty simple, pretty straightforward. We basically push water into it and see how much water can get into the concrete, which gives us an idea of how much contaminants it will be letting into the concrete. We can do these tests before treatment and after treatment, which gives us an idea of where we're going and how effective the treatment's been. So the client can have peace of mind that what's being done is working, and we can give them an idea of what extent it's working to as well. Hayden, do you want to touch a bit more on what we said about acting early, how important that is?
Yeah, cheers. No, it's good. It's good points about getting into actually seeing what's happening inside the concrete. It's so easy, and there's a lot of visual inspections that take place. You see consultants go out, visual inspections, even visual mapping, with technology nowadays. But what's we probably back off about actually getting to the root of some of the issues, that what's developing inside the concrete. So good point. Acting early, as I spoke about at the start. Thanks for those questions coming in too, by the way. We'll get to those at the end. So acting early, proactive maintenance. So that's about thinking about it now, so to save for the future, essentially. And it's like what can be done at this point on a new structure, what can be done on maybe managing or assessing a existing structure that's got signs of corrosion or high chloride levels, things like that. What can be done now to extend the service life? So some of you will be familiar with this model, Turdy's model of the service life of concrete structures. Now, what's essentially showing here is you've got a period, see, relatively flat line between A and B, somewhere in there, and then that sharp curve skyward, and that's showing that if we let corrosion settle and take place, it's a very sharp curve and short time span to the destruction phase. And in that period of A and B is when we need to act in view of pushing out that curve and pushing out the need for maintenance, pushing out the need for rebuild cost and disruption and things like that. So I think the point is we can obviously, if we get in super early at construction, that really extends that curve. We can't quite flat line, but you can make a big difference on your structure and for your client or your own asset in view of giving it more service life. So It's interesting. It's interesting thought. Australian Concrete Repair Association put this out recently again as well. But what essentially they're saying here is De Sider's law of fives, and $1 spent in construction phase, or say $1 million extra spent in the construction phase, and results in savings at multiples of 5. Say phase D would be the point where corrosion's got to a point, and you're talking of knockdown rebuild. But the point is, if we spend a slightly more at that point, when we've got time to think about, when we have got the ability to act, we're saving huge amounts of time and money through those phases. But the point being also, if you don't get it in phase A, you can still catch it in phase B, and push out that curve, as I was saying, and you're still saving essentially a lot of time. So I hope that makes sense to all the audience there. Let's feel free to pop some more comments in if you need that explain more. But does that make sense, Doug?
Yeah, it's good. Yeah, and just what you finished off with there. If we can't get it right at the start, if we can get it in those second and third phases, we're still in a multiple of 5 or 25, whichever way you look at it. Times more cost effective than if we did nothing and let it go right through to major repairs.
That's good. So
good points, guys. So it's quite going back to that point you guys just had there before. If you go back to the maintenance challenges I mentioned beforehand, don't restrict your budget just because of the dollar value. If you look at that actually blows it right out. So over a number of years, it's going to cost you a lot more money. So on to the next one, guys. So what is a concrete hydrogel? So treating concrete with a catalytic silica introduces the formation of calcium silica hydrate hydrogels. So I might just hand over to Brad, and Brad can explain a little bit more to you as per the slide that's in front of you at the moment.
No, that's good. Thanks, Chris. Yeah. So you probably heard us mention the hydrogel a bit so far during the webinar. So this little picture here just shows what the hydrogel is doing inside the concrete. So it's a penetrating treatment, or else it can be batched into the concrete itself. But what we're looking at doing is stopping that moisture movement that can happen via the porosities of the concrete. So those blue lines on the screen represent the porosity going through the concrete. That obviously varies from mix to mix, but all concrete has those porosities in it. So what we're doing essentially is creating the hydrogel inside those porosities and stopping that moisture movement through the concrete. So that moisture movement, as we said, is what's taking those contaminants into the concrete and starting off that deterioration. So pretty important to look at that and see what we can do around there. Doug, I think you had some examples of some other infrastructure examples, and especially around getting in early and acting at that phase A that you guys have been talking about.
Yeah, thanks, Brad. Yeah, the first one I've got here is the Garden Island project. So this was in Sydney there. What was unique about this project was not only the fact that the structures, the precast was protected right from day one. It was actually protected in the precast yard. So the precast was sprayed before it even left, before it even was on the trucks to go to site, which was a massive advantage in terms of logistics, in terms of construction programming, that type of thing. So this structure here, right from day one, it goes into a marine environment. The airborne chlorides, and in the splash zone, things like that. They can't get into that concrete. They can't start that deterioration process right from day one. Did you have anything more on that one, Brad?
No, I think it is important though, especially with that acting at phase one, acting early, is that the solution that we do put forward, or that does get used, has to be workable for all parties. So in this instance, as you've gone over, the construction timeline and programming wasn't affected at all. So a good solution from that point of view. Does that agree with that?
Yeah, I do. Yeah, that's good. Thank you. The next one there was the Glebe Island. So this was a structure that actually had salt loaded onto it. So not only being in the marine environment, subject to the aggressive, airborne chlorides, that type of thing, it also had been accelerated by the salt piled on top there. and that use had finished, and basically they wanted to keep the structure in that condition. They weren't 100% sure on what the next use was going to be, and I still don't know to this day what the structure is used for. But point being is that it wasn't in too bad a condition at that time, back in 2014, and they wanted to keep it in that condition, put it into a holding pattern so that, you might say this is acting early before any major signs of damage, were showing up. I'm not sure. Does anyone know what Sydney, Brad, Chris, what they've done with the structure to date? Or?
Yeah, I might jump in there, Doug. Ironically enough, it's actually, there's a DA in process there to repurpose this wharf DA for a new concrete ready mix supply off that, and potentially a second one as well. Plus, there's some talk about bringing raw materials in by ship or by barge for the construction industry. So basically concrete on concrete at the end of the day, ironically. So
ideal. Yeah. Relates perfectly.
I suppose it does show that you're preserving that life again, like the example of Bledisloe Wharf that Brad shared, that rebuild not only cost, but the environment and the impact around cement and production, again, is saved by preservation. So no, it's good. It's good examples.
Right, now let's have a look at some of the questions that are coming. I'll just bring them up on the screen here.
There's still time to whack a few more in, guys, if you
definitely
on your mind.
So the first one there is this one comes up pretty much every presentation. We probably should include it earlier on. How much does this cost per square metre? Throw that one to you, Hayden.
Great question. Yes, obviously it does come with a cost, but it's what I would say, and probably what I say every time, is it's very project specific. We work with you guys to work out exactly what the needs are, what you're trying to achieve. Is it purely around sort of curing and anti-dusting, or are we going right into to protect the existing structure against that's already got chlorides or may have low cover, things like that. It comes at a different, I know you're going to say, okay, you're just saying depends, but we can, and then the other side of it is you can do it different ways. On a new construction, you can put it through admixture, which, so you're getting it right through the mix and the cube, or on a structure, you can spray it per square meter, and some structures need a clean down and things. So probably the best thing to do is have a quick chat to us, send in a plan, things like that. We'll have a quick discovery meeting, and then we work out a cost structure that works for you. If that's hopefully that's helpful there.
Yes, as a percentage of the overall cost of the project, it's very low. It's not almost insignificant there, but it is an important part.
Very low, and sometimes the access and things to a bridge structure can obviously, as goes into it. But I mean, would probably in most projects you'd see on an existing project you'd see it well under to the $50 a square meter to make sure you've got a treated and secure, resilient structure.
Definitely. Right. The next question here is what sort of warranties are available in a new construction situation? Good one for you, Brad.
Yeah, thanks, Doug. So all our systems and solutions come with a standard 15-year warranty, but a little bit like the pricing side of things, we are also project specific as well, and it depends, once again, whether it's a new build or an old build. And what we're trying to achieve from it. So on a really old structure, we will need to have a look at condition assessments, do our own assessing of the structure before we can see how long we can warrant it, depending on what state the structure is, obviously. But the product itself will last for the length of the structure, so there's no issues there. It's basically just assessing it, what's needed, what can we offer to the best solution on what's needed. Does that make sense, Doug?
Yeah, it does. Yeah, definitely. And yeah, whether that's yeah, I guess the key point being project specific. There's so many different factors to give a definite answer, if you like. The next question there was, how long does the hydrogel last before retreatment's needed? I can take this one. So what Brad's just covered on about it being part of the structure, part of the concrete itself, is really, it is there for the life of that structure. It more comes down to what service life we can extend, or how much we can extend the service life of a structure, really. And, if it's which comes back to the condition that the structure's in. So if it's a structure that you're only looking for, it might be 20 years, 25 years service life out, the hydrogel is going to still be there at that 25-year period. But, we can talk about it being useful for that period, and, help you in your asset management, that you're not going to need to have any further spend in that area. But if you're talking new structures, it is, if it's inside and once it's inside the concrete, the hydrogel's set up, it is there for the lifetime of that project. And in some cases we match the design life of that project, in terms of what we put there as a warranty. Hayden, you?
No, that's good points. That's good points. Warranty always comes up, and obviously it's a well, for an engineer and you on the call, it is actually our brand and reputation at stake, isn't it? When we're signing off things, so we want to know what's backing us, and there's verification to make sure we can make those sort of calls. So hopefully that helps.
Just on that, one of the things that does give us a lot of confidence around our warranties and the treatment lasting a long time is we do a lot of our own installation as well. So we'll supply the product, install it, and obviously work earlier than that with the design and making sure we have come up with the needed and the right solution at that time.
Cool. Just while you've got your mic on, Brad, the question around that, obviously a lot of these are in waterways and marine environments. Tell us about how it acts with the marine life things.
Yeah, so further treatments and whatnot. Being a penetrating product, we can warrant further works on it or further works can be done on it, without voiding the warranty. So the product itself can penetrate 150 millimeters of concrete, get deep inside the concrete. So what we're trying to do is get past that first layer of steel reinforcing, which is very important to protect that, which can cause a lot of the deterioration issues. So obviously we do need to be careful of what we are bolting on or putting onto the structure, as this not only for our treatment but for the structure itself. You don't want to be going down into that concrete reinforcing and pretty much putting a direct pathway that moisture can get there. So it would depend, but essentially if you're keeping under that concrete cover amount, it won't affect what we're trying to do. So, and then if we're using admixture, we're all the way through the concrete. So in that sort of situation, would say as long as it's under 75 mil. Add anything to that, Doug?
No, that's good. And I guess with that, anything, as long as it's designed to be installed or applied over concrete, it's compatible with a hydrogel treated surface or structure. The last question we got there is, how do your systems make the structure more durable from initial build stage? Give an example of a bridge. So I guess there's the first topic I'd like to cover there is around the curing. So these hydrogels can be used to cure a structure, which a good cure on any concrete, and make sure design strengths are achieved. It ensures that the cracking risk is mitigated, is managed. Then I guess the main point is that right from day one, whether it's an admixture or a spray applied treatment, the moisture's stopped from moving around in that concrete. And once you stop that moisture moving around, you stop you stop contaminants being drawn into the concrete, to the reinforcing steel. You stop ASR, things like that. DEF, expansive forces that happen inside the concrete. You stop them being fed by the moisture. That would be the main two areas, I think, from an initial stage. But yeah, just stopping that right from the get go, I guess, and not giving that deterioration any chance to set in.
Yeah, just could jump in there, but it's important to note, we sort of mentioned earlier about what's happening inside the concrete. On a brand new bridge, the concrete cancer or ASR, whatever's, actually starts straight away if moisture's getting in there, but you just won't see it till 20, 30 years down the track when it actually starts cracking the concrete and breaking out.
Brilliant. This another question's coming here. Do the Akron products cause an issue for marine life? Are they an issue for fisheries officers and permit conditions? Hayden.
Yeah, good one. And with that, you'd probably add in things like potable water, thinking of those sort of reservoir structures and things like that. So it's a topic that comes up a lot. It's good. So we do a lot of work around this to ensure we comply in all these sectors, and all the backing with it. So short answer is we do not cause issues for this, these type of environments, which is brilliant. Point being is it's a nil VOC product, waterborne, and it's the way we apply it also is in a method where there's no need for containment and catchment, things like that. So very easy from a public and marine life point of view of existing structures, etc. So it's really good for that regard. Now we do a lot of work with like Green Building Council Australia, New Zealand, and environmental certifications, working through our EPDs and things as well. So spend a lot of time in that space just to make sure the environment is protected. So good point. Thanks for that question. So no issues. And one more there. Looks. Thanks for the questions coming through, guys. Do your systems products need to be specified? Who wants to take that one away? Doug, what do you think?
Well, ideally, they do. It's a lot easier when you get to the construction phase of something's been thought about, something's been put through the paces, if you like, in the design phase, and it can just roll on and happen. We would like to be involved with you in that design, that specification stage. Consider what's actually needed for the project and how that's going to be, how the best way is to implement, whether it be in protection via an admixture or a spray applied curing treatment, whatever it may be. I think everyone would agree here that, yeah, definitely getting in that specification stage, whether it's a need, I would say it's a need personally, makes life a lot easier. What about you?
What it does, I suppose, is it gets it into the budgets and the minds from the outset. If especially for speaking of new work. But then again, if existing structures and things, you can't. I mean, apart from a condition survey, you can't exactly get a specification in there. So it's not all about specification, but it does help because it's written into the build. It's gone through council regulation, things like that, into the build. So hopefully that answers some of those points. Thanks very much for the questions. Let's just have a quick look at the takeaways before we sign off and let everyone carry on with their day, which no doubt you have got a pile of work waiting for you. So appreciate that and your time here. So key takeaways here, got a few jotted down, but probably the one I want to pick out is acting early and really going deep, having a good look at what's going on inside your concrete, and then making the right decisions early to protect these key structures and key investments. What do you think, Chris?
Probably one for me is the reducing the concrete replacement. Obviously, the carbon emission thing is a big concern moving into the future. So that plays a major part in new concrete manufacturing. So one extra point I will say is if you can't see it on the surface, it doesn't mean there's an issue under the surface. So that's just a passing comment from myself. What do you think, Doug?
Yeah, I'd take the first one there, really, that, it's important to be thinking about this, thinking about durability, service life, right from design specification stage in construction, making sure that it's, it's actually happening, that we're getting a good result on the ground, and then that not forgetting about that ongoing maintenance, looking after the structure as it's, it's put to use. Getting that, making sure that 100-year design life is achieved, whatever it may be. Brad, what's your key point?
Oh, one of the things I did like that came into the questions was about how long can we make the treatments last? How long can they be durable for? I thought that was good. Look, when we're looking at ways to improve structures, that's definitely got to be something we think about. We don't want to get stuck in a maintenance cycle where we're coming back to repair or treat a structure every 2 or 3 years. So making sure what we're doing is going to last a distance and save us that maintenance long term. Thought that was great.
Brilliant. Trust that was helpful, everybody. There go our email addresses. We'll leave that on for a few seconds so you can fill up Brad and Doug and Chris's inbox with spam, and then and a couple of phone numbers there. But yeah, look forward to hearing from you all. Look forward to working with you on any projects that you may be thinking of. But more so, thank you so much for joining, and thanks for continuing learning and taking on the new technologies. So appreciate your time. Thanks, panel. Thanks for your insights.
Thanks all.
Thanks, everybody.
Saving the world, one concrete structure at a time. Markham, adding life to concrete.